Hello, cybersecurity professionals. Hope everybody's having a lovely day. Today's topic of discussion is going to be encryption versus hashing. Let's start with the first one, that is encryption. We'll begin with the definition first. So, encryption is a two-way function that takes plain text data and turns it into an undecipherable ciphertext. Okay, remember these words. It's a two-way function and it takes the plain text data and turns it into a ciphertext. Hashing, on the other hand, it's a one-way method of hiding sensitive data using a hashing algorithm. Hashing turns a plain text into a unique hash digest that cannot be reverted to the original plain text without considerable effort. Okay, so the words you need to remember here is one-way function converts a plain text into a unique hash digest and it cannot be reverted. All right, now let's try to understand hashing a bit more. So for hashing, we take our input file, okay, and run it through a cryptographic hash function, and it literally generates a message digest that looks just like this. A random set of numbers. It literally looks just like this. Okay. Now, as I said earlier, it's a one-way function, which means if you give it input, every time the message digest is generated, it's a fixed length. Now, the length of this hashed message completely depends on the type of hashing that you're using. Okay, so now there are many hashing algorithms that you can use. So some of them I'm listing them here. The most common one, MD5, it's been discontinued as there has been it's been found that hashing collision is something that happens. Now SHA-1 is also said to be discontinued. So the most popular ones you would find around are SHA-2 and SHA-3. Some of them which you would not find a lot talked about is the Whirlpool, the Tiger, and also the cyclic redundancy check. Alright, so these are types of hashing algorithms. Okay, now that was about hashing. Now let's come to encryption. Now, encryption is a bit more complex and it's got two types of encryption that you can use. Either the encryption can be symmetric or asymmetric. Alright, let's try to understand symmetric first of all, or what is a symmetric encryption. So in this one, we take the plain text. We use a key, okay? Remember this key. We use a key. It's a mathematically generated key, and then we encrypt that message. Now that message is converted into an encrypted text. Now we use the same key and decrypt it and convert it into a same plain text. Now pay attention to the process again. So we used a key for encryption and we used another key for decryption. This time it's the same key, and of course mathematically also the key is the same. So since it's symmetric, it's the same key that you use to encrypt and decrypt a message. Now there are many types of symmetric keys, right? Here are some examples. The first one is the most strongest one known to man so far, which is the Advanced Encryption Standard, AES. Blowfish, Twofish, RC4, that's revised cipher, that's stream cipher, and the Data Encryption Standard. And of course there are many more, but these are the ones you would most come across, and giving some of these would be a good example. Next, we move on to asymmetric encryption. Now, before I go ahead, what's something important that you should know? The asymmetric encryption uses something called PKI, or public key infrastructure, sometimes also called as public key cryptography. Okay, that's something that needs another topic or another video that needs to be discussed, but just to let you know, PKI is very important for asymmetric encryption. Now let's try to understand this with the help of an example. So you've got your plain text once again, and you use a key to encrypt it, and then you get the encrypted text. This time you use a different key to decrypt it. Okay, why do you use the different key? That is where PKI comes into picture. Now keep in mind that these two keys that you use to encrypt and decrypt are different keys, but they are mathematically connected to each other. Okay, so one would be called a private key and another one would be called a public key. You could use either of them to decrypt and encrypt, but remember, if you use a public key to encrypt, you could only decrypt it using a private key. The same way, if you use an encrypt using a private key, you can only decrypt it using a public key, because they are mathematically connected to each other. And of course, to give you some example of asymmetric encryption, there are some types of. So we've got our first one, that is ECDSA. We got our revised Shamir and Edelman, RSA, the most commonly discussed one. We got a Diffie-Hellman, which is also used for out-of-bound sharing of keys. And then we have your email privacy, that is PGP, pretty good privacy. There are many more, so I'll leave some links down below so you can explore more on asymmetric encryption. Now, here's a quick table to put it all together so that you can understand the difference between encryption and hashing. Of course, we'll start with the definition first. So if you recall, by definition, hashing is always a one-way function. Encryption, it's a two-way function. Encryption and decryption is what happens. In terms of reversible, irreversible, of course, encryption is reversible, so you can convert a plain text into a ciphertext. Again, this ciphertext into a plain text using your PKI. Hashing, it's irreversible, so if it gets converted into hash, you just verify the integrity of the file, and that's it. Length of the file. And for encryption, it totally depends on the type of encryption algorithm that you're using, so it has variable length. Now for hashing, if you use a certain type of an encryption algorithm, it'll generate a fixed length. So for an MD5, it's a fixed length character. For a SHA-3, it'll generate a fixed length character. Of course, the output will depend on the file that you compute for that hash value. Type for encryption, we got asymmetric and symmetric. Remember, symmetric, same key. Asymmetric, different keys. Hashing, well, of course, it's a fixed length, so just hashing is what's taking place here. Examples or common algorithms for encryption, you got advanced encryption standard, RC4, data encryption standard, RSA, ECTSA. Hashing, MD5, SHA-1, SHA-2, SHA-3, CRC32, Whirlpool, and Tiger. Now, of course, in terms of gaining knowledge, this was just an introduction. If you would want to explore more, read more on this, you would have to explore some of the links that I'm linking below so you can gain more knowledge on how encryption and hashing are being used in real life scenario. Alright, and with that, I'll end the video. If you like the video, go ahead and share it with your family and friends whom you think would benefit from this video. And at the very least, share the video and comment if you would like to see more content in cybersecurity. Alright, I wish you all the best. Bye now.